This is the thermal insulator required practical revision video for triple only. So for cooling, you could use liquid. You need a lid in to prevent heat loss through the top from convection. We'd need a thermometer to measure, to record the temperature. You'd make sure you've got the same volume of water or liquid, whatever you're using. You'd make sure you've got the same starting temperature, and you'd have the same mass of insulation if you're comparing different insulations. You could do this experiment instead of having different insulations. You could do it with different thicknesses of insulation and record how much heat is lost, how much temperature is lost over time. You could also do an insulation practical. Instead of it cooling down, you could do it heating up, where you'd have a heat source which emits radiation, where you've got a material that I've shaded in black here that's trying to heat up, attached to a data logger recording the temperature. You'd put your different material or thicknesses of insulation there. So for example, if you're investigating what the effective thickness is, you'd have the same material but with different thicknesses. Or you could do different materials, so you could have cardboard versus bubble wrap versus felt. But you'd obviously have the same mass if you're doing that. If you're plotting a cooling curve, it should start at the same temperature and it would decrease over time. It would eventually plateau at the room temperature. If you were to be asked about the rate of cooling, you would draw a tangent and then you'd do the change in y divided by the change in x to get the gradient. That would be the rate. Rate equals gradient, which is the change in y divided by the change in x. And this bottom line here, this one has got the greatest rate. It is decreased in temperature most rapidly. So that's the worst insulator. Whereas this one, the temperature's decreased very slowly. So it's the best insulator. So it's got the lowest thermal conductivity. And if you were graphing up the temperature rise of this experiment, it would look a bit like this. You'd have the same starting temperature of room temperature. Some may increase rapidly, some may increase less rapidly, some may increase gradually. And the increase in temperature will show it's the best insulator. So therefore the lowest thermal conductivity. And this one's increased rapidly and it's plateaued, so it's reached a maximum. And at this maximum, it's dissipating as much energy as it's gaining from the heater. Again, you could be asked to calculate a rate, and again you draw a tangent, do change in y divided by change in x to get the gradient, which would give you the rate. Be careful about your variables in this practical. Think about your control variables. What can you keep the same? So mass of the insulation, or the thickness of the insulation, the mass of the water, the distance from the heat source, lid. Dependent variable is what you're measuring, which is the temperature. And your independent variable is either your type of material or your thickness of material.